Hi everyone, Gierki here, and today I would like to give you a little update on my open world framework that I am building like for a year already in Godot 4. And it's an open world framework where you can render 8 kilometers, you have a dynamic weather, day and night system, and 8 different biomes. The core idea was and still is that I want to make a framework on which I'm gonna make multiple games on. And before I was thinking that I'm gonna make a VTOL game, a vertical takeoff and landing vehicle game, where you can fly with a VTOL and trade with other cities and towns. And I decided that actually before I want to finish the other one, I would like to explore the waterways and the water stuff. So water is going to be a part in the VTOL game anyway, so I thought maybe instead of making the VTOL game, I'm gonna make a pirate game. I hope that makes sense, okay? So let me show you what I was working in the last weeks on. So before I already had a pirate ship with buoyancy, and I thought that I would like to improve on that. So I have bought an asset pack, my first asset pack ever, for 30 bucks, and that's one of those ships that came with this asset pack. And yeah, there was a lot of work just to like remesh or add some details and stuff and just make it for the game really ready. So as you can see, our sails and masts are actually moving with the wind. So my first implementation for the new direction that I'm heading with the game was implementation of wind. So we have on the top a small flag which is indicating the wind for now, and the masts are calculating the vector of the wind, and yeah, it's moving in the direction where it's logical to be for a mast. So for example, if we just change direction here, the mast is again also changing direction. And yeah, also the entire sail is a shader, which is basically moving the vertices and just simulating how the cloth would react to wind. So if you sail against the wind, the cloth will be just flattened out, and if you sail with the wind, the cloth will just spread out. And yeah, it's a vertex shader basically. So yeah, we also have a rudder here on the bottom. You can see that it's moving and changing depending on what input you give it. And for me, it was very important to input a lantern here, which is lightening up at night. So I can actually show you how it looks like. So let's go to the cheat menu and change the daytime, and we can repeat that and repeat that, and we have night now and the lantern lightens up. But for the purpose of the video, I'm gonna switch it back to daytime. So yeah, it's for me that makes the ship feel really alive, and so that was really important to implement. Next we have the buoyancy system, which already was in the game, but it was really rough and unpolished, and I think I have found a really good way how those buoyancies are working now. It's really smooth now, it's dampening everything as you expected without getting jerky and wiggly like it can happen when you just roughly and fast implement it like I had before. So I would like to give you a small look under the hood, how it's set up, for example, with the buoyancy system and the masts. So let me switch here to the engine, and let's select our smaller ship, our sloop. And as you can see here, this is our ship, and we have our colliders here, all of them, and they are actually the ones which are moving with the wind. So we have here this script, it's called ship sails rotator. You set the state on which it should fold or not retract but extract, no, like deploy the sails, right? So we want this sail, for example, to deploy at half sails, and that's just a correction value for the second mast here. And you can set here like how much the maximum degrees for the sails is. So right now it's just moving maximum 30 degrees to the wind, but you can set it to 90. It wouldn't make sense, but yeah, I found out that these values are the best standard values. So that's how you set up the sails, basically. They have a collider, so when you fire with a cannon against it, so it damages the sails, health bar, and it also changes the shader. I will show you later. And here we have our buoyancy probes. So basically the rigid body, which is this one, is trying to find, it's finding the buoyancy probes in its children. And the buoyancy probes, every single one of them is, for example, here is the front right probe, and it also has those particle emitters. So as soon as this probe detects that it's underwater and it's going a certain speed, like here we have 5 to 10 kilometers, and it's deployed under -2 and maximum 10 depths of water. So it's starting this animation, particle effect, right? And our buoyancy probes actually is, because I don't want every single probe to process by itself, I want the buoyancy probes controller, actually should be called, to go over all of them and wait 0.1 second before it goes to the next one. So we have better performance for everything. And to be honest, in 0.1 seconds, those buoyancy states, if it's underwater or not, don't change as much. So yeah, we have one controller which is just going over all of them, and yeah, that's how it's working. Okay, so that's how the buoyancy system and the sails work. As for the wind impact on speed, it's actually a pretty cool attempt that I had here. So if I go back to the engine, we have here the rigid body, and we have here under sails the wind efficiency. So for example, let's say that we are perfectly aligned with the wind. Our efficiency that we have for moving forward is just 80%. So for example, if I move into the wind here like this and I'm moving forward, we have just 80%. Why? Because one sail is just overlapping with the other one, and so we just have 80%. But let me go, I'm gonna go back to the curve. If we are here at an angle of 20% or even at 50%, we have 100% efficiency, which means in game, so if I'm moving like this, like 90 degrees to the wind, we have 100% efficiency. And if we go totally against the wind, we have 0%, or just a little bit, let me check. We have just 10% efficiency. You can also change this curve actually into the minus area. So if you go against the wind, it actually blows you back, and you don't move forward. But I found out that for gameplay purposes, it's actually better to just have like 10%, and the ship just slowly moves forward, and it feels much better. So we can actually accelerate against the wind, which is not realistic, but it's for gameplay purposes much better. So we are going right now at 5 kilometers an hour, and if we move in the wind, we go much faster. So yeah, that's it for ships and sailing mechanics. Okay, so let's go to the next topic. Weapons and combat system. So we have cannons on board, and if we press the aim button, like we had in a VTOL before, the cannons get deployed. And that's basically not made by an animator or anything, it's made by a tween. So I have to get all of the positions at the ready or enter tree method that we have, and then we are just tweening between them. So how does it look in here? So basically we have I call it gun doors. And we have just a tweening speed of 1 second and a stay armed duration of 6 seconds. So after 6 seconds it moves back. So as you see here, I don't really set it up in the inspector here, because I set it up so we have the retracted cannon here. Let me just turn off those sails so we can actually see something. So we have actually one node for the retracted position, and we have one node for the cannon, which is also actually the real cannon back later. And basically we have it in the same order than the cannon. So cannon number 1 is the cannon which is in position, and then the retracted position is the retracted position on position 1, if that makes sense for you. And basically on the enter function we are capturing all of those meshes by script. So it's called ship gun retracted. And so we know that the first cannon, the retracted position is this one, and the arm position, or actually the, yeah, let's say arm position, is here. So we are tweening between those two. And because we don't need those meshes anymore and those positions, they are stored inside of the rigid body, so we can actually also delete them. That's how I made that. And the same goes actually for the hatches here. We are just trying to find all of the hatches with the ship weapons door, and I set it up in Blender this way that the hatches rotation is already the deployed rotation, but if we just zero everything out, it's just a closed rotation. So let me make this disappear. So as you see, it's the closed rotation here. So that's, and we are also tweening between that. So I'm trying to get out to just not use any animators as far as possible. So that's why I'm using tweening here. Okay, so the end result looks like this. Now it's buggy. Let me reset that. Okay, so everything is reset now, and if we deploy our weapons, they actually move into position. And the same goes also for the bigger ship. So it's basically the same setup, but it's just more nodes. And if we press the arm button, the hatches open and the cannons move into position. And after 6 seconds, we have the inverted tween, so the cannons move back and the hatches close. Okay, so let's go back to our ship here. And what would be cannons without actually firing them? So we can aim at a target, and our cannons, if we press the aim button, are calculating a trajectory to actually hit the target. So as you can see, the cannons have recoil, so they move back, and after 5 seconds of reload time, they again tween into the same position. Because we have different kinds of hitboxes, it would be pretty cool to have different kinds of ammo, and that's basically what I did. So if we go back to our engine here, we have our ship cannons, and we can go to our cannon scene, and here you can see which kind of projectile we are spawning after we shoot. And at the projectile itself, we can define if it's a cannonball, or it's a chain shot, or it's a grape shot, which makes different kinds of impact depending on the hitbox that you're hitting. So for example, cannonballs are pretty efficient against hull, it makes the maximum damage, but it's weak against sails or against crew. Chain shots are really good against sails, so it makes double damage, but makes normal damage against hull and crew. And grape shot makes really good damage against the crew. So how does it work with the detection itself? So basically, if we go back here, like I said before, we have here our colliders for our ship, and we have multiple ones for the entire ship. So I was actually modeling those colliders inside of Blender, and then I turned it into how is it called, in a convex polygon shape, because convex polygon and rigid body works together. And here basically you can set up which collider type you have. So I created this class rigid body 3D collider, and here we can just say which type we have. So we have hull, sails, or plates, because we want different kinds of behavior. So for example, if we hit hull, we want the hull health bar and the crew to get damaged. If we hit the sails, we only want the sails to get damaged. And if we hit the plates with whatever shot, we want it just to bounce off. And here you can also set up the hit effect. What happens if the sail... Do we have the sail? Yeah, rope is basically sail. It's the big one. We have this spawn effect here, which is just this here. Yeah, this is not final. Like, I just made this for prototyping. Okay, so let me show you the ship damage shaders that we have. Everything is built in the shader itself. So if we go, for example, here on our sail material, we can go on our damaged sail material, which is a different one because it's a little bit more complex than the normal sail, and it looks like this. And we can dynamically change the sail damage. Why am I showing this? Because it was right now really hard to hit the sails for demonstration purposes, so I'm showing it just here in the engine. Okay, the same goes for the entire hull. So we have this damage material for hull, and basically as soon as our ship gets hit, it swaps out all of the materials with the damaged ones. It creates unique materials per ship, so it only has like one unique material per ship, and that's how I handle performance here. So that would be the entire destroyed one and the healed up one. So that's that. And yeah, the shaders are basically displaying the health bars, which I had for debugging purposes, and I turned them off for now. They are going to be implemented in the UI soon, so you're gonna see on your target the different amounts of health bars, what you have, and some information like distance, what kind of ship it is, and the name, and what it basically wants to do, and all of this information that you just basically need for gameplay purposes. So something I'm really proud of is the entire camera. Before it was always just focused at the ship, at the middle of the ship, and the ship was in the center. I took inspiration from Assassin's Creed Black Flag, where every time you move the camera to the side of the ship, the entire camera just like peeks around the ship. So you can see it right now, that if we turn the camera to the right, it moves the ship to the left of the screen, so we have more view of the entire area actually. And it comes really it is really practical, because it just looks cinematic now. And the same goes if you target something, like for example this village, and if you move the village on the left side of the screen, the ship is going to get moved on the right side on the screen, and the same vice versa. If nothing is selected, the ship is using just the forward position as just to show just to move the camera. Okay, so if we switch targets and we move the target on the right screen, yeah, it works like this. Very practical in combat. So we are moving right now to the next area that I also did, and I modeled in like 3 hours some buildings which are going to display our villages and harbors. This is just a rough model that I did, and so we can just populate everything. So if we zoom out and change the weather again, maybe we can see a little bit more. So that's all those markers are just the visible line of sight villages that we can see from our ship, and they're basically much more. You know what? I'm gonna show you. Let's spawn our VTOL and take it over and drop the cargo. Oops, drop the cargo. And now if we fly higher, you can see much more markers. Now we have much better line of sight to everything. So I basically reworked the entire spawn script for villages, and now they spawn more efficient and you can spawn them much closer. So my idea is to spawn them between 1 and 2 kilometers, so the travel time is not too far from village to village, and you can have faster gameplay basically. Yeah, so now there is only one point more to say, and it's something that you could hear the entire time, and it's the sound effects that I have implemented. And yeah, I'm pretty happy with the end result. So you have all of those wave noises, and if you stop, for example, you only hear the cracking sounds of the ship. You have the sounds of setting sails and of cannons, hatches, the crew when it reloads the cannons or is ready actually. And yeah, that's it for sound. I think it was the easiest to implement and the most expensive actually. What's gonna happen next? Basically, the next thing I want to do is calculate the paths from one harbor to the next. So basically, it's gonna be a pathfinding system that I'm gonna make. Let me change the weather. Yeah, that's a good one. So we can have trading routes from village to village. You saw before how many there actually are, and every harbor, every town is going to have at least 4 routes to the nearest ones, and then we can spawn some ships which are going to travel to the next harbor, so we have more like AI NPCs going on in the game, and that's gonna put more life into it. Also important for that step is to actually write the code for the ships, how they should navigate. They're gonna get a list of points of the A-star pathfinding, and they have just to navigate with wind in mind. So if the pathfinding says, okay, you have to go to this blue village here, for example, and it's totally against the wind, so they have to like a little bit go off course and just figure out how they can get there with the highest speed possible. Yeah, and that's gonna bring a lot of life into the game, and it's gonna feel much more gamey like. Okay, so that's it for this development update. I hope you liked the video. Make sure to subscribe to the channel or join Discord for more development updates. Or you could even wishlist it on Steam, because the Steam page is already available. That would really help out. So, thank you for watching and see you next time. Bye.